Okay, welcome to the law of sines. Okay, so sometimes in life you don't have a right triangle, so SOHCAHTOA goes bye-bye. Okay, so now what you need to do is have another way to solve them. Well, we have the law of sines and also law of cosines. Unfortunately, for the final exam, they do not give you these formulas. You have to have them memorized. So, I'll give you my tricks of the trade that I use to memorize them, and we'll go from there. Okay, so a triangle that does not contain a right angle is oblique. You probably forgot that. An oblique triangle will have either 3 acute or 1 obtuse, 2 acute. Okay, and again, here's 2 pictures. All right, for an oblique triangle, given the length of a side and any other 2 parts, we can solve the triangle. So, as long as they give us 1 side and any other parts, whether it's 2 more sides, 2 more angles, 1 angle, 1 side, something like that, we have these values. And again, these are not given to you. So, if you have the law of sines, you have angle, side, angle, side, angle, angle, side, side, angle. Any combination of those will be law of sines. If you have 3 sides, which would be side, 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 or 2 sides and an acute angle between them, you'll have side, angle, side. You will use law of cosines. Now, law of sines is pretty easy until you get to one specific case that we'll get to eventually. But to start, we're only going to focus on the 2 easier of the 2. Angle, side, angle, and side, angle, angle, okay? So, first of all, law of sines is really complex looking, but it's really not that bad. And unfortunately, I always write it like this, okay? And it doesn't matter which way you do it. I typically use sine on the top. You guys do it however you want. Either one will do. Unfortunately, they put 3 inequality, or 3 equals, 3 ratios. You don't use 3, only 2. So the way I look at it is, I like to look at it as sine of an angle over the side opposite that angle equals sine, okay, sine of another angle, we'll call it angle 2, over the side opposite that angle 2. And that's all you need. I don't memorize A's, B's, and C's. So you need sine of an angle over the side opposite that equals sine of an angle over the side opposite that. That's all. So, the ratio of length of the side of a triangle and side opposite is the same for all 3 sides. Any combination to apply, we need to have 1 complete ratio and 1 piece. That's what this says. I memorize it this way. You guys memorize however you want. All right, going to our first problem, we're going to solve this triangle. Remember, solving the triangle, we're going to find the missing values, okay? So, all right. So, easy enough, I can find angle C, okay? Find angle C. So, step 1, find the angle C. So, how are we going to do that? We're going to take 180 minus 48 minus 105. If you do that correct, you'll get 27 degrees, okay? So, we know that. Now, write 1 complete ratio and use the 3rd piece to fill in a part of that ratio. Okay, so, let's say we solve for A first. So now, we have 48 goes right to A, and we have 27 to 105. You don't want to use 27 degrees here to C because you'd have 2 unknowns, A and C. So the one ratio you know is 105 to 27. So I like to do sine 105 over 27 equals sine 48 over A. Now it's a ratio or proportion, so ratio or proportion, so you want to cross multiply and solve, okay? So if you cross multiply and solve, this is going to give us A is equal to 27 sine 48 over sine 105. You type that in your calculator and you will get approximately 20.8. So now we know A is 20.8. And again, it says round to 1 decimal place. Okay, round to 1 decimal place. All right, so now choose another set of ratios. Well, now I want to solve for C. I'm still going to use this, and then I'll use that ratio. So I'm going to take sine 105 over 27 equals sine 27 over C. So we're going to solve that by how?
I don't know, but
All right.
there's a problem. 48, but it should be 180 minus 105.
I did have that right there.
No, 180 minus 105, but instead you put the lowest number first.
Okay, well you can do that now when you're big kid math. All right, have a seat. All right, so we have sine of 105 over 27 equals sine of 27 over c. Cross multiply and solve, so you're going to get c is equal to 27 sine 27 over sine 105. Type in a calculator and you'll get approximately 12.7, okay? 12.7. All right, so have we solved this triangle? Yes. We now know A, B, and C angles, A, B, and C sides, so we are done. All right, so on your own, solve this problem. Pause the video and do so now. All right, so now, first thing you want to do is draw the picture. I don't know if you know that. That's what I would do. Maybe you did, maybe you didn't. And label just A, B, C. It doesn't really matter which way. Angle 32. B is 78. And side C would be opposite C is 57. So, first thing you want to do is what? Solve for that angle. So, you should have gotten angle C is 70 degrees, okay? So, hopefully you did that. Then, it doesn't matter what you solve if you want to solve for B or A. I'm just going to solve for A first. So, I have sine of 32 over A, and then you know that you have 70 and 57. So, you're going to take sine 32 over A equals sine 70 over 57. Okay? So then you cross multiply and solve. You should get A is approximately 32.1. Okay? So that leaves me with B. So now I'm going to solve for B. Again, I'm still going to use 70 and 57. So I'm going to have sine of 70 over 57 equals sine of 78 over B. Cross multiply and solve. You're going to get B is approximately 59.3. So hopefully you got all those answers. All right. Next page, please. Now comes the ambiguous case. No. So now comes the ambiguous case. And this is very important. So when we have side angle side, okay, side angle side. Side angle angle and angle side angle. If we get to a side side angle case, okay, that is called the ambiguous. Why is it ambiguous? Here are some examples. Okay, you can have no triangle, one oblique triangle, or two triangles, okay? And it all depends on the height. It all depends on the height. It all depends on the lengths, okay? So when doing this, you have to check all the different lengths, all right? All the different lengths in order to compare them. So if side A is less than H, the height, well, you can't have a triangle. It's too short. If side A equals side H, that means it's this side, then it's going to be 1, okay? 1 oblique is if A is bigger than H, and then, if A is bigger than B, okay? And then lastly, if H is the smaller of A and B, then you'll have that type of triangle. Okay, so this first one is an example of no solution. So, solve a triangle where angle A is 28, 12, and 38. Rounds measures to 1 decimal place. Now, we know this is no solution. I'm going to show you why, okay? So, we have sine of B over 38 equals sine 28 over 12. Again, A to A, B to unknown. So you're going to go ahead and solve it. You're going to get sine B equals 38 sine 28 over 12. Again, cross multiplying. Again, we're looking for an angle, so you want to take the inverse sine of that. If you do, you're going to get angle B is approximately 1.5. Now, why is that important? Okay, why is that important? Well, it says that 1.5 is greater than 1, so you have no triangle. Again, no triangle. Now, on the final, I haven't seen them put an ambiguous case. I doubt they will. So why is it no triangle? Well, the height of this triangle, okay, so A is less than H, so A or B is 1.5, which is greater than 1. So, all right. So, when you go over here, okay, when you go over here, sorry, I did this wrong over here. First of all, I'll show you why it's greater than 1. So you type in 38 sine 28. Gotta make sure you're in the right mode. That's key. So 38 sine 28. So 38 sine 28. Okay? Divided by 12, and you get 1.5. Okay? So, watch. If you try to take the inverse sine of 1.5, you get an error. Why? Because the domain of sine, remember the graph, goes from 1 to negative 1. So 1.5 is bigger than 1. So guess what? Can't do that. All right? Can't do that. All right, so now we're going to do this one. Solve the triangle. All right? C is 68, B is 13, C, round measures. Okay? So again, we have sine 68 over, okay, over 15 equals sine of B over 13. Again, we want to solve for B. Okay, so B equals inverse sine 13 sine 68 over 15. Again, I just cross multiplied and solved. Type that in the calculator, you get about 53.5 degrees. Now, why is this two answers? Well, I'll show you, okay? I'll show you, okay? So, you have to check when you take inverse sine. Remember, inverse sine, if sine is positive, which this is, can be in two quadrants. So if I tell you this is 53.5, what other quadrant do you want to be in? 53.5. So we want to find that angle. So you're going to take your calculator, you're going to take 180 minus 180 minus 53.5, and you get 126.5. So now we have two possible triangles, but this says one solution. Well, guess what? One of these angles doesn't work in a triangle. How do you know? Well, if you have a triangle, okay, if B equals 53.5, you can solve that, okay? So by taking 180 minus 68 minus 53.5, and you get 58.5. All right, so if you try it with 126, however, you're going to get 180 minus 68 minus 126.5, and that's going to be negative 14.5. So notice, in this case, you can get an angle. In that case, you can't. It'll be negative. So what do we know? One solution. Okay, one solution. All right, so this one is very blurry, but
Can I read it?
you have it on your paper. It says two solutions. So we're going to solve the triangle when B is 28. Angle B is 28 degrees. Little b is 10, a is 18. So again, we're going to set this up as
Sine 28.
sine 28 over 10 equals sine A over 18. Okay. Now,
It looks like a 98.
it does. So it's 18. Okay, so now we're going to go ahead and solve that. How? By cross multiplying, you'll get A equals inverse sine of 18 sine 28 degrees over 10. All right? So type that in a calculator, you'll get 57 degrees. Okay? 57.7, sorry. And again, in our unit circle, that would be the equivalent of taking 180 minus that. So if you take 180 minus 57.7, you get 122.3 degrees. So now we have two possible answers. So it says solve the triangle. So now we have two answers. We have 57.7 and 122.3. So this has two answers. Let's see if it works. So we're going to take 180 minus 28 minus 57.7, okay, and you're going to get 94.3. Then we're going to take 180 minus 122.3 minus 28 equals 29.7. So I have two possible triangles. And from here, you can solve them by using the law of sines still, okay? So if you look in the notes packet, I did include all that, of how to solve that. All right, so last but not least, we have area. We're going to use area is 1/2 BC sine A, 1/2 AB sine C, 1/2 AC sine B. So it's always the two sides and the angle, two sides and an angle, two sides and an angle, and the way it's set up is the angle is always opposite neither of the two sides they give you. So find the area of a triangle with given measurements. So we have side A, and again, I'll draw a picture in case you need it. A, B, C. So we have 87, B is 10, C is 23. So we want to find the area, so we're going to take area equals 1/2, and we're going to take, we have sine angle A, so we're going to take 1/2 sine, or 1/2 10 times 23, okay, and sine 87. Okay, type that in a calculator, and you'll get approximately 114.8 feet. Okay? Now, here's some application problems, okay? Go ahead, Nate.
A helicopter is on a path directly overhead line AB when it is simultaneous observed from locations A and B separated by 200 feet. If the angle of elevation from A is 39 degrees and the angle of elevation from B is 20 degrees, what is the distance from each location to the helicopter route?
All right, so we're going to get started on this. So we're going to call this side B, side A. We're looking for B and A. Okay,
Yep.
so it's like solving the triangle. So angle of elevation from A is 39. Angle of B is 20. Don't do it, Ava, please. Okay, thank you. All right, so angle of elevation is 33 or 39, and then angle is 30. Okay, so all we're going to use law of sines, right? That's all. So we're going to use 39. So we're going to take sine of 39 over A equals sine. We're missing that angle. So how do I find that angle? Well, you're going to take 180 minus 39 minus 20, and that's going to give us 121. So this angle is 121 degrees. So it'll be sine 121 over 200 cross multiply and solve, you're going to get A is equal to, all right, A is going to be equal to 200 sine 39, okay, over sine 121. So A is approximately going to be 147, sorry, feet, okay? All right, so that's A. Now we can find B. We're going to use the same 121, 200, and so we're going to take sine 20 over B equals sine 121 over 200. Go ahead and solve that. Pause the video and see what you get. All right, so B is approximately 80 feet. All right, so that's how you do that problem. All right, last problem, okay?
To estimate the height of a building, two measurements are taken. The first measurement shows an angle of elevation to the top of the building as 43 degrees. The second measurement takes 100 feet closer to the base, yields an angle of elevation of 78 degrees. From these measurements, estimate the height of the building. Round to the nearest one.
All right, so first and foremost, draw a picture. That's my advice. So in this picture, you're going to have a weird picture with two triangles, okay? Two triangles. So first of all, we have a building, okay? So the first measurement shows angle of elevation is 43. The second taken 100 feet closer. So this one is the farther of the two. That's going to be 43. And then we're going to do it again, all right? And we're going to measure it a little bit closer, and it's going to be 78, okay? So that's our measurements. So we know that we have this measurement, 100 feet, because it's 100 feet closer, all right? So now, how do we figure this out? This is the tough part, okay? So we want to find some of these distances. So that is x, okay? So good news is we have a right triangle. So this triangle here is a right triangle, okay? So in that right triangle, you could use SOHCAHTOA, you could use anything you wanted for that. So what we're going to do is we'll just use law of sine since that's what we're in the section. So we're going to take we're going to use this triangle here. I'll outline it in pink, okay? We're going to take this triangle here and outline it in pink since we know this 100, okay? So we're going to take this 43, 100, x, and we're going to find that. Now here's the other problem, okay? We need to find this angle right here, okay? That angle, well, how do we find it? Well, these are a linear pair here. They make 180 degrees, so this is 102. Take 43 plus 102 and subtract from 180. You'll get 35 degrees there, okay? So now I have everything I need to know. So I have the 35 is opposite the 100, so I'll take 35 sine 35 over 100. That's this 35 to that 100. We're going to take 43 to x, okay? So sine 43 to x. And that's going to solve x for us. So if we did that properly, you're going to get x is approximately 11. So this is 11. Now that we have that, I'm going to use SOHCAHTOA. Why? It's easier. You could use law of sines again, but that seems like a waste of time there. So we want to calculate this. We'll call it h for height. So we have opposite and hypotenuse. So we have sine of 78, okay, equals h over 11. Cross multiply, solve, however you want to do it. You should end up with h is approximately 116 feet. Now that concludes the lesson on law of sines.